Solve and graph the solution set. So we have a compound inequality here. We need to solve these individual inequalities, and then we can take the intersection in this case because we have an and statement. So we'll solve the individual inequalities and then we'll take the intersection of the solution sets. Looking at this first one, it looks like we want to add 2 to both sides. So we get 3x is greater than or equal to 3. Then dividing both sides by 3 gives us x is greater than or equal to 1. Going on to the second one, we want to subtract 1 from both sides, giving us 2x is less than 6. Divide both sides by 2 to get x is less than 3. So we graph both of these on our number line. We've got 1 and 3 greater than or equal to 1, strictly less than 3, and then we take our intersection because we have an and statement. So our intersection is going to be this part right here, just the overlap, remember. Match the brackets. So we have the interval from 1 to 3. Square on the 1, round on the 3. Going on to our next inequality. Same idea. We don't really need to think about the or right now. We're going to think about that after we're done solving the individual inequalities. So if I subtract 8 from both sides, I get negative 3z is greater than negative 3. Divide both sides by negative 3. And don't forget your rules for solving inequalities. Because I divided both sides by a negative number, I do have to flip this inequality symbol around. So that becomes a less than instead of a greater than. And I have a z on the left and a positive 1 on the right. Going on to the second inequality, subtract 2 from both sides. It's getting a little crowded here, so I'll let it sort of move over just a bit. That gives us 3z is greater than 9. Divide both sides by positive 3. I don't flip the inequality symbol this time because I'm dividing by a positive number, so I get z is greater than 3. Again, marking both of these numbers on the number line. Z is less than 1, that goes to the left. Z is greater than 3, that goes to the right. And because this is an or, we take a union, which means we want to include both of these disjoint intervals in our solution set. Going on to our next two inequalities. These are both and statements because they're written in this sort of compact form, but we don't have to break them apart into and statements and solve them individually. We can solve them in place as long as we do each operation in all 3 places. And what I mean by that is we're going to focus on getting this x alone. This x is in the middle. I know I need to add 1 to get that minus 1 away from the x. If I do it in the middle, I have to also do it on the right and the left. I can't just do it in 2 out of the 3. I have to do it in all 3 places. As long as I do this in all 3 places, I can solve this inequality in this compact form quickly. So I now have negative 6 is less than 3x, which is less than 12. I now have to divide by 3 to get that x alone. If I'm going to divide by 3 here, I have to do that also in all 3 places. And this then becomes negative 2 is less than x, which is less than 4. This is an and statement, right? We know that because it's in the compact form. So as I mark these numbers on the number line and read these inequalities. First, x is less than 4. That's from the 4 over to the left. Second, thinking about this other side of it, x is greater than negative 2. Remember to read backwards from the x. X is greater than negative 2. That's why it is that it starts from the negative 2 and goes to the right. And my intersection, again, is the overlap. Round brackets. So my answer is the interval from negative 2 to 4, round brackets. Going on to my very last example, I'm going to follow the same basic process, but first I'm going to clear fractions. My LCD is 10, so if I multiply all 3 locations here by 10, then that will clear my denominators. Let's see what we have left in each place here. On the left-hand side, the 10 cancels with the 2 and gives us 5. In the middle, this 5 in the denominator cancels with the 10, leaves us 2, and on the right, this again leaves us 5. So, on the left-hand side, 5 times negative 1 is negative 5. In the middle, we have 2 times 3 minus x. And on the right, we have 5 times positive 1, or just 5. I'm going to choose to distribute this 2 into the parentheses here to give us negative 5 is less than or equal to 6 minus 2x, which is less than 5. And now I can start focusing on moving things away from x. I'm going to start by subtracting 6 in all 3 places to give me negative 11 is less than or equal to negative 2x, which is less than negative 1. Next I'm going to divide by negative 2. Remember that if we're dividing by a negative, we have to flip the inequality symbols. We're going to flip both of them around, but we flip them around in place. So this less than or equal to becomes a greater than or equal to. This strictly less than becomes a strictly greater than, and then we can figure out what we should have left in each of these places. So we have 11 over 2. That becomes positive. It was negative divided by negative. In the middle we have x, and on the right we have again positive 1/2. So over here on our number line, 1/2, 11 halves. X is greater than 1/2. X is less than or equal to 11 halves. Again, reading that inequality backwards. And filling in the overlap so that we know this is our actual intersection. Again, we know we want the intersection and not the union because this is an and statement, and we know that it's an and statement because only and statements can be written in this compact form. So we go from 1/2 to 11 halves with a round bracket at 1/2 with a square bracket at 11 halves.